Okay, I'm gonna talk about my second Capstone project, which is fraud detection, and why I choose this fraud detection dataset because I was working with different datasets in the past, and the difficulty that I had most of the time with imbalanced dataset and what we should do with them and what is the proper way to tackle those. So I'm gonna use fraud detection, but we have this problem. I mean, the imbalanced data set in some another domains such as disease screening, subscription churn, ad serving, and maybe other areas. And what are the several approaches to solving imbalance problem before starting the classification is using different metrics such as F1 score and recall, using more samples, using techniques such as oversampling, undersamplings, or any combination of those that I will talk about that later in this video. But at the first step, I read my dataset, which is the credit card dataset, and it's a CSV file. It has 31 columns from time V1 to V28. Actually, I don't know exactly what it means V1 to V28, but it's financial metric for transaction that we have in our dataset. We have the amount column, which is the amount of transaction in each credit card tab. And we have the final class, which is 0 and 1. 0 means non-fraud and 1 means fraud. And as you can see, the shape of our dataset is 284807 by 31 columns, which is a lot of data point that we have. So definitely we have some computationally problem at the end if we don't have any GPU. At first step, I just see one of the information about this dataset. Is there any null values in our columns, which hopefully we don't have? Uh, is there any duplicated rows in our dataset, which we had around 1000, so I drop all of the duplicates? And you can see the problem here when we count the value of class column, we can see that just 473 of those is fraud and others is non-fraud. If you see here, you can see that 99.8% of those is non-fraud. So it easily you can just with a blind guess, you can say, okay, this is fraud, and 99.8% you're correct. So accuracy is not a good metric for this dataset. Uh, for the second step, I'm just gonna pre-process the dataset. Hopefully we don't have any categorical column to turn it to the numerical. All of them are numerical, but we have to rescale the amount column because as you can see, the V1 to V28, all of them in similar scale. But for amount, we have to normalize that. So I use the standard scaler and create a norm amount from amount column. And I add this to our dataset and drop the amount and time. We don't need that time too in our dataset. At the second step, I choose X and Y. X are features, which is all of the columns except of the class, and Y is our output, which is the class and it's binary class. For the splitting our dataset, you can easily split the dataset to train and test, but because we are dealing with imbalanced dataset, I'm going to use stratified sampling, stratified splitting. What is a stratified splitting? It means that at the end of the day, when you split your dataset into train and test, the distribution of the test is exactly the same as the distribution of the train dataset. And you can do it easily with the stratify equal to y. So I split the dataset to train and test. And after that, I just use random forest classifier on our dataset, and you can see that we have average recall score is around 76% just for random forest classifier. And I used recall instead of accuracy because accuracy is not a good idea here. We are dealing with imbalanced dataset. But if we use hyperparameter tuning using grid search CV for different types of algorithm, such as decision tree, random forest, logistic regression, SGD classifier, we can see which one is working well. But the dataset is so big, so it takes a lot of time for me to run this part of code. And at the end of the day, we have uh, this result. The best accuracy that an F1 score actually that we have is related to logistic regression and decision tree and SVC. But the best one is SVC, which is 99.9. But it's not perfect. Based on the number, you maybe you think that, oh, this is the best classifier that we have. But because you're dealing with imbalanced dataset, it doesn't add any value to our ML work. So we have to put it away and go for some techniques to first deal with imbalanced dataset, and after that apply these types of algorithm on that. So uh, it's not good actually that we have 99% of accuracy, and you shouldn't accept that. It's not realistic. The first technique that we can use is random oversampling. What is oversampling? When you have some minority classes and majority classes, you can create, for example, in this dataset, some other data points related to the fraud to make it more similar to each other, to have more items from fraud detection. But what is the problem with oversampling? It just create exact copies of some of the rows that we have. But this is a way that we had actually. So I used oversampling, but unfortunately I don't have the result here in the code because I actually applied that before and actually run that before with the GPU. But with oversampling, we had around 83% of accuracy. Another technique that we have is undersampling. What is undersampling? It's deleting some random rows from the majority classes, which is non-fraud rows. It's not a good idea again because it's turned to loss of information. You lose some of the rows in your dataset. But so I never gonna use this approach, but I just explain it a little bit to know that there is a way such as undersampling too. Another way that we have is a smooth. What is a smooth? It's something that's like oversampling with a minor change. What is that? It doesn't copy uh, the data point that we have for oversampling, but it create some rows very similar to the data point that we have. So based on my understanding, it's the best way to tackle this problem. I mean the imbalanced data set. When I used smooth, we had an 87% of accuracy. Uh, why I'm telling accuracy? Because after you change the imbalanced dataset to the balanced dataset, you can actually use it accuracy. This was the best way. Another way is using class weight. What is class weight? Class weight is an argument that you can use on the classifier, on the parentheses on the classifier when you create the object, each classifier, and you can use it and you know uh, assign balance to that. That means give more weight to the minority classes in your dataset. And after using that, we had a 82% of accuracy, which is not bad and not good. But the best way actually was a smooth with 87% of accuracy, even with grid search CV for different types of algorithm. Yeah, that was my second Capstone project, and my goal was exactly uh, dealing with imbalanced data set and what is the technique that we can use for some kinds of data sets such as fraud detection, disease detection, and something like that. Thank you.